Hi everybody, today we're going to continue to talk about logarithms. I'll cover common logs, natural logs, conversions from exponential to logarithmic form, and then from logarithmic form to exponential form. We'll also cover a few basic properties that'll be really helpful as you're working with logarithms. To start off, let's talk about what it means to have exponential form and logarithmic form. Exponential form looks like x equals b to the y, so I have an exponent within my equation. Logarithmic form looks like the log base b of x equals y, so I have a logarithm in my equation. Let's practice changing to exponential form. We're given the log base 3 of x equals 5, and we want to write it as an exponent. To start, I want to identify my base, which is going to be 3. I'll raise 3 to the power 5. Then we write that this is equal to x. This says 3 to the power 5 equals x is equivalent to the log base 3 of x equals 5. Let's try that again with the log base 6 of x equals 4. We start with our base of 6 and we raise it to the power 4. Then we finish our circle by saying this is equal to x. Let's try one more. Log base b of 3 is equal to 2. We use our base b, we raise it to the power 2, and we say that that is equal to 3. Now let's go in the opposite direction. We'll practice changing an exponent to a logarithmic form. We're given 2 to the 8th is 256. It's important to note that the base of the logarithmic form will be equal to the base of the exponential form. So 2 to the 8th becomes log base 2. Then the exponent goes on the right side of the equation. That says log base 2, I still don't know of what, is equal to 8. To finish it off, we grab the last piece, which is 256, and we put it over with the log base 2. So I have the log base 2 of 256 is 8. Another approach is to take the log base 2 of each side of the equation. That says the log base 2 of 2 to the 8th is equal to the log base 2 of 256. Because I have the log base 2 of 2, we know that the answer is just going to be equal to 8. So I can write 8 is the log base 2 of 256. Let's write the log base 4 equals 12 into logarithmic form. I know my base is b, so I write the log base b. We know the exponent of 4 goes on the right, and 12 goes with the log base b. We have two special cases of logs that we'll use a lot. The first one's called the common log. Common log is the log base 10 of x. So when you see a log where the base is not given, it's understood that that base is 10. Log base 10 can be found in scientific calculators, which makes it easy to evaluate common logs. Let's find the following using our calculators. We'll start with log 1. It should give you 0. Log of 10 will give you 1. Log of 100 will give you 2. If you do log of 0.1, you'll get negative 1. Log of 0.01 gives you negative 2. And log of 0.001 gives you negative 3. A second log that's very helpful is called the natural log. We write natural log as ln of x, and it's equal to the log base e of x. Let's find some values using our calculator. We'll start with the natural log of 1, which gives us 0. Natural log of e will give us 1. Natural log of e squared will give us 2. Because natural log and common log are in our calculator, we can use them to find logs of any number. They do not have to be powers of 10 or of e. For example, I can find the natural log of 26, and here you can see I've rounded it to 4 decimal places, so I have 3.2581. If I do the natural log of 0.005, I've rounded it to negative 5.298. I also have the natural log of 38,000, which I rounded to 10.545. I'll quickly go to Desmos to show you how you could use those. I can open the keyboard and you don't see log, but I can type log in and then put a number, like let's put 10, and I see that I get 1. I could type log of let's do 1,000 and you can see I get 3. I could also type natural log of 26 and there's the 3.2581 that we had. I can type ln of 0.005 to show you we get negative 5.298. And let's type in the natural log of 38,000 to see the 10.545. If you want to see the actual key inside of Desmos, you would hit Functions and you go down to Calculus. In calculus, you can see the same log log, you can see ln for natural log, and you can also see log base A, which lets you change the base of a logarithm and evaluate any logarithm that you would like to do inside the Desmos calculator. To finish up our talk today, let's talk about some properties of logarithms. We'll start generically with log base b, then I'll do the special cases for common log and natural log. Our first rule says the log base b of 1 equals 0. This is true for any base b, where we already know b is greater than 0 and not equal to 1. The log base b of b is always going to be equal to 1. The log base b of b to the x is equal to x. Then b to the log base b of x is also equal to x. So here we really see the inverse properties of logs and exponentials. If we apply these rules to the common log, that says the log of 1 is 0, log of 10 is 1, log of 10 to the x is x, and 10 to the log of x is x. But most importantly, let's look at the basic properties of natural logs. These are the ones I use the most, and you will probably see the most as you go to solve logarithmic and exponential equations. So we start with the natural log of 1 is 0, natural log of e is 1. Then the natural log of e to the x is x, and e to the natural log of x is x. Let's do a quick practice to see what that looks like. We'll start with the natural log of e is 4. So don't grab your calculator, just look at the fact that natural log and e are inverses and our answer is 4. Now let's try natural log of e to the 3x minus 2. Once again, all I have to do is bring down the exponent, which is 3x minus 2. If I have e to the ln of 6, my answer is 6. If I have e to the natural log of 5x, my answer is just 5x. Hopefully this shows you how helpful these properties are. You just have to recognize when they're being used.